Hi, my name is Raghu Aris. This recording is to showcase the work done for CMPE 258 Homework 2 Assignment Part 1. In this assignment, I had to actually demonstrate a simple hello world example for two endpoints with AutoML tools from Google Cloud Platform. So as part of this assignment, first, I had to actually register for Google Cloud Platform with one of my accounts. So I had used the SJSU account ID to register for Google Cloud Platform, through which I got a trial version with which I was able to perform this assignment activities. So once I had registered for Google Cloud Platform, the first step was to create a project. The project was created in the GCP platform, which allowed me to continue with the rest of the assignments for AI platform. So as part of the AI platform, there were five different classifications which was showcased. One was the hello image data, for which the first step was to create a project. Inside the project, we had to create a storage bucket. There were certain steps provided by the AI platform unified, which was followed through in this assignment to perform this activity. So there was a gutil command which was provided with which the Google bucket was created. Once the Google bucket was created, they had given a data set inside, which was to be leveraged for this assignment. And they had provided the URL from which the Flower data set could be downloaded. So upon downloading the data, they had explicitly showcased that even though the data was loaded, if there are more than one annotation, the message would be showcased, which needs to be dismissed. And post that, you'll still be able to see there was 3,667 images that were loaded. This data was loaded onto the new bucket, which was created in the step one. And once this data was loaded, we were able to train the model using the navigation on the left navigation here on the training, or once the data is loaded on the right side, it was popping up that you will be able to train the model. Using this option, I had continued over to train a model. And for training that model, the GCP tutorial provided the steps as what needs to be selected. And for that one, I had selected the default annotation set and the AutoML option with which this model had to be trained. Post the model training was invoked, once training was completed, it took some time. Then these are the steps showcasing what are the options that I had selected and the budget was selected. And once that training was performed, using this option of deploy and test, an endpoint was created using the deploy endpoint. And for the deploying endpoint, the endpoint name, any name could be given. And then the train split, the traffic split was specified to be used as 100%, and the compute nodes were selected as 1. Post that, the endpoint was generated. Once the endpoint is generated, you'll be able to see that the model output. It's going to take some time, but once the model is available, you'll be able to see that it generates the confidence threshold. It showcases what is the confidence threshold and a confusion matrix for the training, whatever it performed was generated. So it was showing the confusion matrix for the sunflowers, tulips, and roses as what is the values that it had done for that model. So post that, we were able to see that the data set was available, and it was available in green, which would be used, which we can use for our prediction. So here, after the model is generated, I'm just showcasing that the model output, which could be seen in the navigation. And once the model is available, you can go into the model and then you can perform deploy and test. And here, by giving a new image from your machine, you'll be able to see what is the prediction that it is giving up. So I had selected a rose image and it was predicting it as rose. And if I'm giving a new model, the new picture, in this scenario, it was a sunflower. I was able to see that it is predicting a sunflower. So once this prediction was demoed, and once I had tried out with the different options, I tried cleaning up the particular project by deleting the endpoint first. And for deletion of the endpoint, went into the endpoint that was created for the scenario. It was the auto image. So AutoML image classification, here it was deleted using the delete option. Once the endpoint was deleted, once it was confirmed, then I was able to, once this was removed, then I was able to delete the model by going into the models and selecting the model and deleting. Then once the model was deleted, I deleted the data set. So this was the first part of the AutoML image classification. So the next part in the part one was the text classification. So for the text classification, it was the similar to the previous thing. We had to actually create a project. The project was the same thing I have used. I have not created new projects for each and every activity. So in that project, I had to create a new bucket for the text classification. So use the command, the gsutil command. Using the gsutil command, I created a bucket, and for this particular data set of happiness.csv, I created the bucket. And once that was done, the data set was generated with the happiness.csv, and that we could see it inside the data sets. For this particular data set, I was training the model. So using the train new model options and selecting the AutoML default options, I had trained the model. So training took some time. Once the training was completed, it was available for our test. So once the model was trained, so this is the output that was coming through. Then after the model is generated, created the endpoint, and from the endpoint, once it is generated, I was able to see in the model that it had shown what was the confidence threshold that it was showcasing. And for the model, whatever was generated, the confusion matrix could also be seen in the below section. The confusion matrix looked like this. So it had for the nature, affection, bonding, and what was the predicted scores, and it was showing how the mapping was generated. And this was the option inside the model in the deploy and test. We were able to actually provide the text whatever we want, and it was providing what is the filter with which it is predicting. So if I'm giving this kind of statement, it said that it was an achievement. I tried for something else, and it says that it is a lesion. So it was predicting the sentiment properly. It was classifying it basically. So once I tested the model, then I deleted the model. First, I deleted the endpoint, and then coming out, then I deleted that model. Once the model was deleted, I deleted the data set which was loaded. The third portion of part A was the video classification. For the video classification, again, went into the data set. Inside this data set, I created a video data set for the video classification. The data set was provided by the Google tutorial. So I've used this split 5 classes all data set. And using this, once the data was loaded, I trained the model. And once the model was trained, I was able to see the model had this kind of threshold value and confusion matrix, which was generated. Once this thing came through, did a batch prediction, went into the batch prediction, and inside the batch prediction, I created a new batch prediction for the model, whatever was being added. And here, when I was actually doing this is a data set, and it was trying to actually do a batch prediction for this kind of data, the video data, whatever we were loading. And once that particular data was done, the batch prediction data was ready, right? We were able to actually view the results. And once we do the view results, we were able to see for the videos, whatever we have loaded, it is actually predicting what kind of value it is. Once I validated the model was running fine and the prediction is coming fine, the classification, I went ahead and I deleted the model by going into the models. The next part of this assignment was to perform a cluster custom classification. For the custom classification, again, using the command line created the tar. So using this, we were able to actually load that particular file. It was downloaded. Once it was done, the training application in the Google storage was loaded. After loading that, we did a custom training pipeline for the custom data set which we had loaded. So this is how the custom training was triggered. And once the custom training was triggered, we were able to see the log of whatever training that was being performed. And using this command line, we were able to actually see the training was completed. Here, using this particular command line, we had to actually create an endpoint. So this is showcasing of how the endpoint has been created. Using that endpoint, whatever was created, this data was deployed onto the cloud function. So once the deployment was done, this data was available in the web, which was ready for some prediction. So this was the site which was hosted onto the web. And opening up the site which we deployed in the previous step, we were able to do the predictions for the images, whatever was present. And this is how the image prediction was coming through. So it was predicting that it is sunflower. Once this prediction was set, once we had seen the model, whatever was deployed, the custom model was deployed is working fine on the website, I went ahead and I removed the endpoint. After the endpoint was removed, went ahead and deleted the model. The next part of the assignment, part A assignment, was the tabular data classification. For the tabular data classification, created a new data set, structured AutoML tutorial. So followed through the steps of the default values. And once the data was loaded, did a training of the model. In the training of the model, I provided the default values, whatever were there. And once the model training was triggered, it took some time. Once the training was completed, was able to create deploy an endpoint. I was able to deploy an endpoint. For deploying endpoint, these are the options that I had selected. I selected the maximum node as 1. Once the deployment of the endpoint was done, the model came through. And inside the model, I was able to see these are the options, whatever which the data that we had loaded with. And here, selecting a different values, I was able to test the data to see what is the prediction. So I was able to get the prediction of 99% confidence score. And once the data was tested, I went ahead and deleted the endpoint. And after the endpoint was removed, I removed the model. This particular screenshot showcases what was the confidence level and the confusion matrix for the model that was predicted. And here it is showcasing what was the feature importance that it had done for the tabular data that we had loaded in the very first step of the custom data load. And once the endpoint was removed, I cleaned up the project by deleting the model. So these were the 5 examples, tutorials that were given as part of part A assignment. And after completing the part A assignment, went into the part B of the assignment. The part B of the assignment talked about executing AutoML vision and time series forecast. It was having 2 parts in itself. So the first part was the entire deployment of vision model using AutoML to a mobile device. So for this one, we were using the Firebase console project. Inside the Firebase, created an account, created a project, ML Codelab. There, I was able to set up an iOS app. They had provided a certain toolkit and a code base for the iOS application, downloaded that. And to perform that, I had to use Codelab. It is there in the next step. So these are the steps showcasing how the AutoML setup was done on Firebase. So once the AutoML Firebase setup was done, it took us back to the Vision API of the Google Cloud, on which we set up that Flower data set. Once that Flower data set was imported, we were able to see that data, whatever was imported onto the data set. So these were the Flower data set of 1,000 images that we had imported. And on that data set, we trained a model. So training of the model on that Flower data set yielded this kind of confusion matrix result. Once that particular thing was done, this step talks about how I installed the Firebase using the ML toolkit pod install command. And for this one, I had ran into an issue during the installation. The Cocoa pods were failing, and then I had to use this link to overcome that dependency issue. So once that was done, this is showcasing the model. The model took some time for it to complete. Once that model generation was done, in the vision, the model value was available here in the TF Lite. Once we downloaded that, it gave through around 3 files. Those files were taken through and then it was exported. So that gave the result here. And that contained these three values. And in the initial second step, whatever model that we had, the iOS application, whatever we had downloaded, that application contained the model. So I replaced those three files here. Once that was done, I had to build the applications. So when we did the first step of the Firebase, we had gotten this plist file. So this is the Google Services info plist file, which we had to replace from the Firebase, whatever we received. And along with that, we had to actually build the model by doing this import of the Firebase. So this was a dependency which I had run into issue earlier using that Stack Overflow fixed this particular dependency issue. And after this thing was done, here again, I ran into another issue because it was giving that it is for Objective-C. And to fix that, I had to quit this, delete the podlock files, then rerun that particular install command, and then reopen the Xcode. Doing that, it installed the Firebase properly, and then the build went through successfully. Once the build was successful, I was able to actually open up the simulator. Here, I used this simulator for iPod Touch 7 generation to actually see how the application is coming up. In that, I was able to see that it is able to predict properly for the images that have been loaded. Whatever images that I was selecting, it was predicting, it was giving a proper result with a good confidence score. After this thing was done, I had to clean up this particular project. For the cleaning of project, I went ahead and removed the data set, removed the model, and then closed down the Firebase project, whatever I had open. So this was the part 2 of the assignment on the Vision API. The next one is on the time series forecasting. For the time series forecasting, I followed through the Colab link for the AI platform that was shared. So as part of this, we are doing we are taking a time series data, and then we are setting up a notebook to visualize our data and create a model on it. So I followed these steps, and in the steps, it talks about how to set up a BigQuery API. And once the BigQuery API was set up, okay, this step, it showcases that I went into that, clicked on that manage, and then I got the BigQuery API enabled. And in API platform, the notebooks had to actually install a TensorFlow 2. The highest version. So I took this then for TensorFlow Enterprise 2.3 without GPUs and did that enablement of the notebook. And for that, once that notebook was enabled, it gave me these options, selected the Python 3. And with that particular one, our notebook setup was ready. And using the training data, whatever was there, explored and started working on the 3 Ipmv notebook files. So the first one talks about the exploration and visualization of the data. And that had certain data points and steps given here as how to create a model and query the BigQuery time series data. So with the API which we had enabled for the BigQuery, took this particular CSV, loaded it up in the BigQuery, saw that the data, whatever we loaded for CTR ridership is available, and then ran that Ipmv file. So here I'm showcasing how the AFI time series, whatever was downloaded, using the skit clone, I cloned that particular data set. And once I cloned it, this data was available. The files, whatever was used to be, need to be used for this training is available. So once that was done, cleaned up this whole project, restarted the kernel and executed all the steps. And while executing, we had to provide our own project name on the region on which we are enabling this and where the BigQuery is enabled. So changing those values, we were able to execute it. And when I executed that, I was able to see that it was plotting out the data properly. So it was actually showcasing the total number of writes and total number of writes by data type. So this was the visual representation of the data, whatever was there. And once that was seen, we were able to actually see the summary statistics of how it is plotting through. So went over that Colab notebook, saw that how the seasonal data and the data has been exported and how it has been coming through. So after this thing was done, created a new data set here using the commands and statements, whatever was provided on the column. And once that data set was created, I took the CSV and I loaded that particular CSV, which I had downloaded in the earlier step. So it came through here, and in BigQuery, I was able to query the data to see that the value is coming up fine. And this is how I was able to load the data into the BigQuery and then see the data coming through on the CSV, which was loaded. Then a model, whatever was done, and then here that particular model output is also coming through. So in the previous step, whatever the model was created on the step 4, so we were able to see that these are the model and this is the model output weekly and by yearly values. Post that, this is showcasing of the execution of the forecast to see how the value is coming through. And this is the legal bucket on which the new bucket was generated earlier. And yeah, this one is about the custom forecasting model. There's the second part of the Colab file of the time series. Here did the installation of the stat models, and once the stat model was installed, set up the project bucket and region. So this is the same bucket which we did in a couple of steps back, where we actually created and loaded the data and did that model execution. So here it was hosted on US Central 1. Post that, executed these commands to actually see the data set, and then this is a loading data set to see what is the value of the data, whatever was being loaded. Then after removing the outliers, this is the value that was coming through, and this is how the result of showcasing the outlier threshold. Then scaling the input and output, performed the evaluation of the model. So a couple of models were executed here. The first one was the Lstm model. So once the Lstm model was executed, it ran through for around 1,000 epochs. So it yielded out the result like this. Then we executed the convolutional neural network model. So convolutional neural network model output was executed, and we saw the MAP and MAE values and R2 values. Then the naive model was executed. This is the naive model output. Then seasonal naive and exponential smoothing as well was executed. Once that was done, we even did the ensemble, ML, and statistical models. So this actually concluded the part, the second Ipmv file execution. Now we went into the third Ipmv file where we did the training and prediction on the cloud. So did the library import and then enabled the project IDs. And once the project IDs was enabled, went through of loading that particular data and then running through the model. So here again, we did the scaling. Once the scaling was done, we created the sequence of the time series data. After that, we prepared that particular data using these commands. And after the preparation was done, we trained the model. So for the training of the model, we actually did the GSTL commands to actually load the bucket. And actually, this is the training of the model. So here we actually provide the job name and then we executed the model. So once that training was done, we were able to see that the data is coming through in the bucket, and this is the values that were populated. And once the model was queued, and then I think it should be, yeah. So this is a job that was created. Once that was done, we actually used this command to actually deploy the model. Once the model was generated, we were able to see that the model was coming through inside the models tab of the AI platform. And once the model was ready, I was able to see this, and using this particular command, we were able to predict the model. And the model prediction gave us this kind of output, and it gave what would be the actual predictors and the predictor rider values. Post this particular thing using the gcloud version delete commands, deleted and cleaned up the models, whatever was created. In this section, we had two challenges which was posted. I had to take up the New York data, and for the New York data, we were asked to perform the notebook files, whatever we had created. So the first one was to actually explore the data. So duplicate the Ipmv file, explore the data, and run the data query. So I went ahead and downloaded the NYC data set. After the data set was downloaded, I loaded that in the Bigquery, executed the query into seeing that they had asked around 3 queries to be executed to see how the query comes through, the query result comes through. So this is how the 3 query results came through, right? So once the data was available, went through with the second step of installing the packages and creating that particular Ipmv file for the NYC31 data. So downloaded the data, loaded the data, did the data exploration, and did the analysis of the pattern. So this was for the first one. And the second one was to take that particular data set and duplicate it and create the file of the model to Ipmv and execute the LTSM and CNN filter. So for that one, I took that particular file, loaded that for my project. And after that, created the cloud storage bucket, loaded the data, scaled the data using these commands. And after scaling of the data, created the sequence of the time series data, evaluated the data, then executed the Lstm model. So once the Lstm model was executed, I was able to see that the output for auto score was coming like this. Then when subjected to the CNN model, the output was getting generated in this manner. So after that, I cleaned up the project by shutting down the TensorFlow notebook, whatever was spun up in the first step of this part 2 assignment. So this way, I was able to execute both part A and part B of the second assignment for CMPE 258. This one is just stopping that. Thank you.